Welcome to the session on functions and graphs, composite functions. The objectives for this session are to combine two or more functions to make a composite function. When two or more functions are combined to make a new function, the new function is called a composite function. If we first apply function g and then apply function f, we have fg of x equals f of g of x. Order is important. Fg of x may not be the same as gf of x. So in diagrams, if we have three sets, we have little x in one set, g of x in the next, and fg of x in the next. So when we apply the function g to x, we obtain g of x, and when we apply f to g of x, we obtain fg of x. And the composite function is fg of x. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at example 1a first. Given that f of x equals 2x squared and g of x equals x plus 2, find fg of 3. So let's solve this. G of 3 is 3 plus 2, since g of x is x plus 2. We've simply, of course, substituted x equals 3. F of 3 plus 2 equals f of 5. And if we plug in x equals 5, in the equation for f of x, we obtain 2 times 5 squared, because of course f of x is 2x squared. And this equals 50. Now for part B. We are required to find gf of 2. So we plug in x equals 2 into the formula for f of x, which is of course 2x squared. And plugging in x equals 2, we obtain 2 times 2 squared. So this now equals g of 8. We plug in x equal to 8 into the formula for g. Of course, g of x equals x plus 2. So g of 8 equals 8 plus 2, which is equal to 10. And now for part C. f of minus 4 equals 2 times minus 4 squared. We've plugged in x equals minus 4 into the equation for f of x. This equals f of 32. And now plugging in x equal to 32 into our equation for f of x gives us 2 times 32 squared, which is equal to 2048. And now for example 2. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 2a first. Functions f and g are defined as f of x equals 2x plus 1 and g of x equals x squared plus 3. Find the function fg of x. So let's solve this. Here's g of x. This is of course simply equal to x squared plus 3. If we now apply the function f to this, we obtain 2 times x squared plus 3, which has taken the place of x, plus 1, as shown. And tidying up gives us 2x squared plus 6 plus 1. And this is of course equal to 2x squared plus 7. And now for part B, we are required to find g of g of x. So of course g of x on its own is straightforward, that's just x squared plus 3. And if we apply g again, we square the contents of the brackets, as we did before, which are x squared plus 3, so we square x squared plus 3 and then add 3. And tidying up gives us x to the 4 plus 6x squared plus 12. And now for part C. We are required to find g of f of x. Of course, f of x is simply 2x plus 1. So we substitute that here as shown. And if we apply g, we square the contents of the brackets, so 2x plus 1 all squared, and then add 3. Because of course g of x equals x squared plus 3. And finally expanding the brackets and tidying up and then factorising gives us 4 times x squared plus x plus 1 as shown. The last part of this example asks us to find the value of a such that g f of a equals 28. We're of course going to use part C, since from part C we already have that g f of x equals 4 times x squared plus x plus 1. Now if g f of a equals 28 for some a, then 4 times a squared plus a plus 1 equals 28. We've simply substituted x equals a into the formula for g f of x. And so dividing through by 4 gives us a squared plus a plus 1 equals 7 as shown. And tidying up gives us a quadratic in a, so a squared plus a minus 6 equals 0. And finally factorising gives us a plus 3 times a minus 2 equals 0. And therefore we have that either a equals minus 3 or a equals 2. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve part A first. Functions f and g are defined as f such that x is mapped to mod 3x minus 5 and g is such that x is mapped to x plus 2 all over 3. We are required to find the value of fg of 3. In this example, we first begin with g of 3. So we plug in x equals 3 into the equation for g of x, as shown here. The equation for g of x is x plus 2 all over 3. So when we substitute x equals 3 into this equation, we obtain 3 plus 2 all over 3. Tidying up gives us f of 5 over 3. And then plugging in x equal to 5 over 3 into the equation for f of x gives us 3 times 5 over 3 minus 5. And this is equal to 0. Now let's take a look at part B. We are required to solve fg of x plus 6 equals minus 4x minus 15. So let's solve this. First we begin with g of x plus 6. Here we simply substitute or replace x by x plus 6 as shown. Tidying up gives us f of x plus 8 all over 3. And now we apply the equation for f of x. So this time, of course, f of x is equal to 3x minus 5. So if we're trying to find f of x plus 8 all over 3, we simply replace x by x plus 8 all over 3 as shown. And tidying up, then tidying up some more gives us modulus x plus 3. So now we've found fg of x, which is of course equal to mod x plus 3. So we're required to solve mod x plus 3 equals minus 4x minus 15. If we sketch the graph, so here's y equals mod x plus 3, and here's y equals minus 4x minus 15, then we can see that the solution to the equation occurs on the reflected part of the modulus graph. So we're going to use minus x plus 3 to indicate this. So from the graph, we have minus x plus 3, which of course replaces mod x plus 3, equals minus 4x minus 15. And then solving for x gives us that x equals minus 4. This brings us to the end of this session. If you have understood its contents, you should be able to combine two or more functions to make a composite function. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to it.